Okay, welcome to DynamoDB for AppSync, single versus multi-table design. My name is Rick Foxcroft. I work for a company called Mechanical Rock as a DevOps consultant. At Mechanical Rock, we tend to use AppSync and DynamoDB for a lot of projects that we work on. I happen to work in that space as well, with a lot of serverless technologies. And I thought I would put this together to demonstrate the various approaches, pros and cons for single table design with DynamoDB, and also how you can use multi-table design with AppSync to build a scalable application. So why use AppSync to begin with? Well, it's AWS's serverless GraphQL service. It allows you to define a strict schema for API access. That means that you can query really complex data types and request basically data types within other data types, which really makes it quite dynamic from that ability to get a lot of data back with one query. And interestingly enough, that also aligns with one of the core value propositions of single table design with DynamoDB, is that you can also make one query, and depending on if you design your schema upfront correctly, you can get a lot of data back related to a particular entity. DynamoDB, just for a bit of context, is also AWS's managed NoSQL database service. Really cheap, really great, really consistently performant. And so this meme right here really sums up the differences between single table design and multi-table design. You can see that the single table design dog is far more powerful than its counterpart. But multi-table design also has its own credits. Multi-table design allows you to separate data by concern. It gives you far more indexes, so it's far more forgiving for beginners. And what more index means to the new AWS user is that you basically have more access patterns for your data, because you can slice and dice on different attributes and query on different attributes. You also get a dedicated stream for each table when you use a multi-table design architecture. And I know AWS Amplify tends to lean towards the multi-table design, but what I'll do is I'll go over the single table design and what its benefits are, and you can make up your own mind. With single table design for DynamoDB, it's really imperative that you focus on your schema up front, lest you lead yourself down the garden path of having to perform a table migration, which in itself isn't too worrying with DynamoDB. It's not too difficult. It's just a case of running a script to pull out all your data from table A and then obviously load that into table B. But generally speaking, if you've used DynamoDB before, you know that it's really important to design your schema up front so that you have all the flexibility that you require for your querying needs. And so that's really, if you focus on designing your schema up front with DynamoDB and put in all the effort to make it, implement a flexible querying approach, you then have the ability to also query on a single value and get back loads of related data to that object. So it really is powerful from that perspective. And this kind of just demonstrates that idea, is that you can have, in this picture, you've got the one partition key that serves as an ID for a particular item, but nested in that item is a bunch of other items. And you'd know this if you've perhaps walked into the AWS console and you've had a look at a DynamoDB table and you're going, whoa, what are all these items that have the same item ID? And it's not actually a case of that item necessarily having the same item ID. It's just that it's stored in the DynamoDB table with that same partition key, and so it looks like it's duplicated data, but it's not really. It's just a bunch of related items that have been grouped together. And so for this talk, you'll notice that to demonstrate a lot of the modeling techniques, I use the DynamoDB NoSQL Workbench. It's a really great tool for modeling data with DynamoDB. It allows you to do things like this, create snapshots and organize the data into various partition and sort key combinations, as well as indexes, and even assign types and display attributes for those items as well. In this presentation, I'll also use a lot of VTL templates. I know just a week ago, by the time this presentation gets out, it'll be a couple of weeks ago, a new feature just got launched that is direct Lambda invocations for AppSync. I tend to still think that VTL templates are still really useful in the context of AppSync, because it means that you don't have to provision a lot of Lambdas that you need to necessarily monitor, and can you concern yourself with a bunch of configuration details for Lambdas. You can just turn on logging for AppSync and get all the logging output for your VTL resolver templates to find out what's going wrong if there are any issues. So I think VTL templates are great for mapping simple objects to something like DynamoDB. I know with AppSync you can also use VTL templates to make direct requests to things like RDS and serverless Aurora, Elasticsearch, even any HTTP endpoint as well, which really opens up the opportunities for a lot of different sorts of query and mutation needs with AppSync. So if we want to think about how we can put all of this together in the context of how do we make DynamoDB work effectively with AppSync, we can create an application, and in this case we're going to create an application called Regia. It's an application that allows us to monitor ongoing projects in our organization, because that's always fun to do. And it also allows us to look at a bunch of great examples of all of the different scenarios that we can use when modeling DynamoDB data to be queried and accessed via AppSync. So to dive into the entity relation map for that application, we can see that in the bottom left-hand corner we've got projects, and each project will have a bunch of tasks, many tasks, and a task can only be assigned to one project. And then obviously you have users that have to be assigned to a project, but a project can also have users, so there's a many relationship there. Over time, you will also gather metrics about a project as well that will need to be reported and potentially displayed in different dashboards. But they'll also come back into the Regia application at some point as well. So to take a holistic view of our initial application architecture, where we'll do a bunch of the intro examples, we have a React Native application that uses the Apollo client to talk to AppSync at an API level to get its data. DynamoDB is our data store for this application, and to map our requests and responses to and from DynamoDB and AppSync, we'll use VTL template resolvers. So to show those mappings, I'll just run through a quick bunch of VTL templates and what their purpose is in this context. So here we have a create project mutation. And just to run down from a top to bottom perspective, you've got a statement at the top that creates an ID for the item when it gets created, and it uses the AppSync util object to create a v4 style UUID for this item. We can also see that in the arguments coming in from this request that we have project details. Now we take that ID that we created initially and we stick that into the project details. You'll also see that on the second last line of this piece of code that we actually take those project details and we use the AppSync utils again to map those values for the project into the kind of schema that DynamoDB expects for item objects. You'll also notice that in our key for this request, we're using PK and SK as our partition key and sort key, and I think that's a great way to go about designing data in DynamoDB. And I'll come back to that later as well, but it basically just allows you a really flexible approach. And also you can see in the sort key that we've prefixed the ID again with just a bit of information to detail what the purpose of this item is. So coming back to that PK and SK naming convention earlier, it's really important that with AppSync that you don't lock yourself into calling the partition key ID. And you'll notice that in the previous request we put the ID into the project details, and that's important because that means that you won't necessarily always have to have an item ID as the partition key, which means that you can be a lot more flexible with your querying patterns. And that's important in the context of Apollo because when you're using Apollo has a normalized cache, and it uses the object ID to index items in that cache. And it's really useful to have that ID in the cache so that Apollo knows how to find that item and automatically update it for you when you get mutation responses, subscription updates. And it's really great to take advantage of those automatic updates because it means that you as a developer from a client application building perspective don't have to worry about managing state in your application, which means less bugs. It's faster to develop because all these things are happening for you if you've designed your schema correctly, and it just works. So stick your ID in your item attributes and save yourself a lot of hassle, prevent table migrations. This is a good example of that same thing with IDs. Here we're using the item ID in the sort key, and we're creating a task that is related to a project. And when a task gets assigned to a project, it gets put into that project's partition key so that it can be queried as part of that project's data. But we'll come back to that in a minute. What we're doing here is creating a task, and here you can see that we're using that project ID for the PK, the partition key, and the ID is the sort key. And so here you can see how that data comes together. Once you've created your initial project, you can then create two tasks underneath it, and they all fall under that that project's partition key. So now, if we wanted to get the tasks related to that project exclusive of the project details, we could use the task prefix that we created for those tasks when we assign those tasks in ID. And it's just a case of using the DynamoDB begins with expression when making that query, and that'll allow you to get all of the tasks related to a specific project when you supply that project's ID. So coming back to that use case of querying for project ID and getting all of that data back, this is a typical use case in GraphQL. You want to get all of the details for a project up front, and so you basically want to make a query like this where you ask for the tasks inside of that project. So how do we handle that with a single DynamoDB query? And I know a lot of people will say, well, why don't you just use field level resolvers that AppSync allow you to make use of, which is basically that means that when you make the request for the project with the project ID, the tasks object has its own query that goes and fetches the tasks for that project as well, and has the context of the project ID in that query. The problem with that is I find that first of all, you're making an additional query for those tasks when you could just be making one query. But what if those tasks have another complex object type inside of them that is also an array? At that point, you're making n queries for each of that object in each task, and you're really increasing the overhead of that query. Whereas you could just be making one query if you designed your schema to cater for that requirement up front. So I'll show you how you can make a single query and get back multiple types for a single project. And to do that, you basically want to supply your query with a project ID and then just execute a single query to get the project where that partition key equals that project ID, and that'll return you all of the items that sit inside of that partition key. And then once you have that array of all of those items in that partition key, so in this case it's these three items we have here, the project details and the tasks. What you can then do is create this VTL response template where you iterate over each of the items that come back in that query, and then map over those items and map them back to a single project object that then gets parsed as JSON and returns the API. And so that's the example where you can make a single query with DynamoDB and return all the related items for a single entity. And in case you were wondering, I've written this blog post. It's on the Mechanical Rock website, mechanicalrock.io. It's called Ensuring Resolvers Aren't Rejected, and it details how you can reverse engineer some of the AWS Amplify packages to unit test VTL resolvers. So go and check that out if that's something you're interested in. So what about many-to-many relationships? These relationships are at most times difficult to reason about. You get the same sort of problems with RDS, where you have to create a lookup table to map those relationships together. And with DynamoDB, it's something similar, but this can be handled really easily with a reverse or an inverted index. And in the case of Regia, the many-to-many relationship we're dealing with is that users can be assigned to many projects, and projects have many people working on them. And so to facilitate that relationship, what we'll do is we'll store the user ID in the sort key of a project item, and we won't put any attributes in there. The reason we'll do that is so that we don't duplicate data and we maintain the original reference to that item in its own item. And so to create the link, you basically create an additional global secondary index with the partition key as the existing table schema's sort key, and the sort key for the new index as the original table schema's partition key. And that allows us to link those two items together. So how you would do that is you would probably have a pipeline resolver that makes the initial query for projects with an ID of, in this case, we can say 6606, and all items that start with user. That will give us all of the IDs for each user assigned to that project. We then create a subsequent query in that pipeline resolver to go and get the user details, where it could be a batch get to get each user item where the user has one of the IDs that have been returned and the project matching ID. And so that sums up our discussion for single table design and how it can work really well with AppSync, and the possibilities it enables when you use AppSync in an application. And so what about multi-table design? Well, multi-table design actually enables quite a few interesting possibilities, and we'll go over those now. But it definitely has its uses in the context of a scalable AppSync application. One of the reasons why you might choose to use a multi-table design is if for some reason you have a versioning system in your application. So in the case of Regia, we might want to create versions of projects or tasks each time one of those items is updated. So if you have a high throughput of data coming into that table all the time, lots of updates, if you're writing versions back to that same table, you're going to create this recursive loop where you're writing back to that table, and that those writes are subsequently invoking that Lambda stream, that DynamoDB stream again. And so to circumvent that, what you can do is create an additional versions table where you create a new item for each version and increment. You could use like a case sortable UUID to facilitate creating a new item version each single time, and that'll also return you when you query for those project versions or those task versions. That'll return you an ordered list of all those versions over time. And so the reason you do this is because when you have that recursive loop, you basically have this influx of logs, and it can make things really difficult to debug, especially if you have a bunch of additional logic that filters out these updates that we essentially don't care about. So that's something really useful to be aware of. And when you go and implement that additional table with that stream, this is what your architecture will look like. You've got that original table, data being streamed into the stream, and then that going into the versions table. VTL templates can then interface into that versions table and request data on behalf of the AppSync API. So this is just a screenshot of what data in that versions table might look like. You can see in the sort key that you've got the case sortable UUID, and next to that the updates that happened for each project update. Another use case for multi-table design in AppSync is that you might have separate teams in an organization, and one of those teams might be working on a bespoke application that pulls existing data out of Regia and uses it to build graphs and metrics that management can use to analyze project performance over time. And so this might be its own microservice with its own API layer and data store. And being a microservice, it means that you can essentially reuse this and integrate it with your existing Regia application. And if you were to do that, this is what your architecture might look like. So here you'd have your existing Regia API, and you'd go through to the new API with, in this case, HTTP endpoint resolvers, and to integrate that new API with your existing AppSync API. If it were an AppSync, if the new API were an AppSync API, you could use schema stitching. So before deploying your Regia schema, what you do is use something like GraphQL CodeGen to stitch those two schemas together. Or if it wasn't AppSync or GraphQL and was something like API Gateway instead, you could create types. You could create the types that you needed and that you were aware of to integrate with that new API and include those in your AppSync schema. And the reason you would have one AppSync schema for your Regia application is it just simplifies things a lot from a Apollo client perspective. Having just one client means that you only have one cache instead of having to reason about two different Apollo client caches in your application. And so that really, really simplifies things from a client application development perspective. And so just to summarize things, a single table design is great for having that powerful single query that delivers a lot of information back to the client. You only have one table to monitor as opposed to many. It also forces you to consider all your access patterns up front, which is great if you really want to optimize that table design. Multi-table design is great if you're a newcomer. You get a dedicated stream for each table. You get, I think you get way more indexes for each table, and it's much more forgiving that way. You also can use multi-tables in a system, in an AppSync application, to monitor internal application state and stream to different tables for things like versioning and such. So thank you for listening. Hope you enjoyed it.